Namaste to all my dear students. How are you? Today I am giving you very interesting term inductive effect that is very important for knowledge as well as examination view of points. So I am talking about the inductive effect. At first we have to know what is inductive effect. That is inductive effects, very important. So when you talk about the inductive effect, what you see over here, so there is partial. So we can say when you define this what you see inductive effect, so in this case what you get, partial shifting of sigma bond in covalent bond due to difference in electronegativity value of two atoms. So when you talk about the inductive effect, what you see over here, it is the what you see partial, better to say it is partial shifting of sigma bond in covalent bond. Why? Due to difference in electronegativity value of two atoms. So at first we have to know what is inductive effect. Sorry, what you see electronegativity. Electronegativity. At first we have to know what is electronegativity. So when you talk about the electronegativity, what it means, the tendency of an atom to attract shared pair of electron present in covalent bonds. So what it means? So when you talk about the electronegativity, so what you see, so hydrogen has 2.1, carbon has 2.5, nitrogen has 3.0, oxygen has 3.5, fluorine has maximum. It has the maximum. Chlorine has again 3.0. Bromine has how much? What to say? 2.8. Iodine has about 2.4. Sulfur has 2.5. That is the electronegativity value. So you have to remember all this. So what we see in hydrogen 2.1, carbon 2.5, nitrogen 3.0, oxygen 3.5, fluorine 4.0. It has maximum electronegativity. Chlorine, bromine, iodine, sulfur. So now we have clear what are the electronegativity and how it participate in what is the inductive effect. So look at very simple example. So what you see? Carbon, that is the Cl. So what the name of this compound? So know that the name of this compound is, carbon is always tetravalent, I have already told you, and always takes place in sigma bond. Yes. So what you see? Chloro chloropropane. We know chlorine has 3.0 value, and what to say, chlorine has how much? 3.0. 3.0. Carbon has 2.5. So according to definition of electronegativity, those elements which have higher electronegativity value, it attracts the shear pair of electrons. So what do you see over here? This is the covalent bonds. So what you see over here? So mutual sharing of one electron. So due to high value of electronegativity, electron of this first carbon is shift to what you see? Chlorine. So it develops slightly negative charge. Yes, when it develops slightly negative charge, it means it has somewhat deficient in electron. So it develops slightly positive charge. It has slightly positive charge. It has positive. So that is suppose 1 carbon, 2 carbon, 3 carbon. So as you go from what to say right to left, so in this case inductivity value decreases. Question arises why? So in first carbon what you see, inductive effect is high with respect to C2, with respect to C3. C3 has what you see minimum. It has minimum, it has maximum. It has minimum, it has what you see maximum inductive effect. Like what you see, suppose when you talk about to get this what you see concept, so we take very simple example like magnet. That is the magnet. That is the magnet. So when, so that is the what you see nail. So we have already seen in magnet. So first nail, that is the first nail, second nail, third nail. So the nail which attracts to the what directly attached to the what you say magnet, it has maximum inductive effect, a magnetic effect you can say. But second has low, third has low. A point will come where there is no any magnetic effect over there. Like this, when you comparison of inductive effect, so what you see in this case, in first carbon inductive effect is very high, like first nail. Second carbon has low, third carbon has low. So what do you see? Inductive value decreases. Why? Inductive value what is it decreases? From first carbon to second carbon to third carbon. So very important over here. So it develops slightly negative charge. Why it develops negative charge? Because it has high electronegativity value. It has low electronegativity value. So what is it? This chlorine attracts shear pair of electron toward itself and it develops slightly negative charge. Delta means what we always slightly, and that is also known as partial. So I have already given you the what is the definition. It is partial what you see shifting of the sigma bond. Always keep in mind where there is sigma bond must have what you see covalent bond, single bond must have what you see sigma bond. Also keep in mind where there is single bond what you get sigma bond. So what you see over here, so I think we have clear. So what is the inductive effect? And inductive effect, what you see, it's partial shifting of the sigma bond in the covalent bond. Why? Due to difference in electronegativity value. So I have already given you what's the data. This data we must learn. It's very important for knowledge. So we are talking about the what's the inductive effect. So in this effect, so we have to know the nature or what is the character of the what you see inductive effect. So character, or you can say simply characters of inductive effect. First one is, it is permanent effect. Second, it takes place in sigma bond, that is sigma bond. Third, it transmits along the chain of carbon atoms. Look at over here. So, when you talk about the characters or nature of inductive effect, what we see over here? First one is, it is permanent effect. What it means? So, what we see, the chlorine atom, when whatever is what this chlorine atom present in this molecule, so always the what you see positive charge develops in this carbon. So, this positive charge develops due to chlorine atom. So, it takes place up to chlorine atom. It means it is permanent effect. Yes. Second, it takes place only in sigma bond. Only in sigma bond. So, I have already told you where what you see covalent bond, single covalent bond, always what we have sigma bond. So, these all are the examples, sigma bond, sigma bond, sigma bond. Yes. So, it takes place only in sigma bond. Yes. Third one is, it transmits along the chain of carbon atom. So, what do you see? In first carbon, inductive effect is very high. Second one is somewhat lower. Third carbon is what you see somewhat less, we can say least. So, what you see minimum inductive effect over here? In this case, maximum inductive effect. It means it transmits from first carbon to second carbon, three carbon to fourth carbon, up to inductive effect, you can say, like magnetic effect. Always keep in mind. So, inductive effect, about the inductive effect concept, always we have to keep the concept of magnet. If you keep the what you see concept of magnet, you have never what you see problem, never difficulty. Yes. So, when we talk about the characters, what you see, it is permanent effect. It means it takes place up to chlorine atom. There is no any change in sigma negative charge, what is delta negative charge. In this case, what you see, in this case slightly positive charge over here. Yes. So, this molecule becomes polar. Where it becomes, this molecule become polar. Why becomes polar? Why becomes polar molecule? Polar molecule means molecule having positive and negative charge. So, in this case, what do you see? It has slightly negative charge, slightly what is positive charge. So, molecule becomes polar. Why? Due to difference in electronegativity. Takes place in sigma bond only. Third one, it transmits along the chain of carbon, first carbon to second carbon to third carbon. So, I think you have clear what you see inductive effect, what are the characters or nature of what you see inductive effect. Next one is, next heading is type of inductive effect. type of inductive effect. In this case, what you see? Negative inductive effect, or we can say positive inductive effect. Yes. So, talk one by one. So, first one. So, first one is what you see? First one is A, negative inductive effect. So, this effect is developed, or we can say produced in a molecule due to presence of electron withdrawing group. For example, so what it means electron withdrawing group? The species or the atom which withdraws the what electron in the molecule is known as electron withdrawing group. Yes. So, what we see? Example of electron withdrawing groups are as follows. First one is, for example, is like this, in the nitro group, cyanide group, what you see, aldehyde group, cyanide group, keto group, acid group, can say fluorine, chlorine, bromine, iodine, alkoxide, what's OH group. Next one is what we say NH2. Next one is that is what is phenyl, or we can say aryl group. So, these all are the example of what we see, what is electron withdrawing group. These all are the example of electron withdrawing group. So, that is it has maximum electron withdrawing nature, it has minimum electron withdrawing nature, minimum electron withdrawing nature. So, think it has maximum, yeah, we can say order of the what you see, it has maximum, then what was cyanide, then aldehyde, keto group, acid group, fluoro, chloro, bromo, iodo, alkoxide, alcohol, you know, amino group, that is alcohol, that is the amino group, that is the what you see phenyl group, or we can say aryl group. These all are the example of electron withdrawing group. Yes. So, when you take very simple example like what you see, we take very simple example like this CCC. Suppose this is what we say chlorine. So it's 3 point, what is 0? It has 2.5. So it develops slightly negative, slightly different, what do you see? Positive charge. That is the example of what you see? Negative, you can say inductive effect. I think likewise, when you talk about first example, second example is nitro group. It develops slightly negative, slight positive, positive. So what we see? Inductive effect decreases. Inductive effect decreases. Yes, it is also the example of negative. Why? It develops negative charge. So what type of force inductive effect over here? Negative inductive effect. Why it takes place inductive effect? Because due to presence of electron withdrawing group. Chlorine electron withdrawing group, nitro group is electron withdrawing group. So it causes what you see negative inductive effect. So I think you have clear. So any negative inductive effect develops in a molecule due to presence of any electron withdrawing group. Yes, so in this case, in this table, what we see? It has nitro has maximum electron withdrawing character, and phenyl has what we see minimum electron withdrawing nature, we can say. So we have clear what is the negative. Next one is what you see when you talk about B, positive inductive effect. It develops in a molecule due to presence of electron donating, or we can say some pumping group. We can say pumping group. For example, R, that is third degree alkyl. It has maximum. So how many alkyl group? 3 alkyl group. All alkyl group are the example of electron donating group. Then what you see? RCRH, that is secondary alkyl group. Likewise, CRHH, that is first degree. Now that is the methyl group. So what we see? It has minimum electron donating properties. It has maximum electron donating properties. Yes. So for this we take very simple example like this. See, in examination you have asked, we can say better to say application of inductive effect. So first one, sometimes ask you questions. So explain why trichloroethanoic acid is more stronger than ethanoic acids. Now look at the what you see. How can you show? So what you see, trichloroethanoic acid is more stronger than ethanoic acid. Suppose when we talk what you say, Cl. So that is known as what you see, trichloro. How many chlorine? 3 chlorine. Trichloroethanoic acid. So what you see, how many electron withdrawing group over here? 1 electron withdrawing group. It means it withdraws the electron when chlorine, 3 chlorine atom over here. So 3 chlorine atom withdraws the electron density from the what you see, acid. So what you see over here, the electron density is very low. In this case, what you see when we talk about the what you say, so that is the example of negative inductive effect. In this case, how many electron withdrawing group? 3 electron withdrawing group causes less electron density in what you see, acid group. It means what you see, so this group, it means it loses proton easily. It means it is a stronger acid. So 3 things we have to remember over here. So in this case, how many chlorine atom? 3 chlorine atom. Due to presence of 3 chlorine atom, it withdraws the what you see, electron density towards itself. So what develops over here? So electron density is very low. So what type of effect over here? Negative inductive effect. Due to presence of 3 electron withdrawing groups, what you see, chlorine atoms causes less electron density in acid group. It means it loses proton easily. So we can say it is stronger acid. Yes. So that is about the trichloroethanoic acid. Now see about the what you say, CH3 COH, that is the ethanoic acid. So you know the nature of all the alkyl groups are what you see, electron donating group. It means it increases the electron density over here. So we can remove the what you see, this acidic gas, no doubt, but with difficulty. So in this case, what type of effect? Positive inductive effect. Why? Due to presence of methyl group. Why? Due to presence of what say, electron donating group like CH3. Yes, it causes more electron density upon acid group. So we can, so it loses acidic proton with difficulty. It means it is a weaker acid. So in short, so in this case, due to presence of electron withdrawing group, it causes less electron density over here. So it loses what we say acidic hydrogen easily, proton we can say. But in this case, due to presence of electron donating group, it increases the what we say electron density over here. So in this case, loss of proton is very difficult. We can remove it because it is the acid, no doubt we can remove it. But in this case, to lose this proton, we have to use more energy. Yes, why? Because the attraction of this O and H is very stronger bond over here. If a stronger bond, so in this case, to break, to lose the what is a proton, it's very difficult, you can say. Yes, so I think this is the weaker acid. Why weaker acid? Due to presence of electron donating group. But it is stronger acid. Why it is a stronger acid? Because it is electron withdrawing group and causes what you see less electron density. So the bond in between what you see O and H is very weak. So it loses very easily. So it is a stronger acid. But in this case, electron density is high. So bond is strong. So we can remove H with difficulty. Yes. Next question is, first one is trichloro. Second question sometimes ask you, explain why aniline is less basic than ethylamine. Ethylamine. Look at over here. So what is aniline? That is known as aniline. Yes. So that is the phenyl group. That is known as, that is what you see, it withdraws the what you see electron toward itself. So what happens? Aniline in this case, due to presence of a, so that is the example of negative inductive effect. Why? Due to presence of C6H5, that is known as aryl, that is known as phenyl group. Yes. So negative impact. So let's see it, phenyl group, electron withdrawing group, phenyl, the group phenyl causes less electron density over amino group, so it is less basic. Why? So due to presence of electron withdrawing group like phenyl group, it causes less electron density over amino group, that is the amino group. So this is the what is weak base. Why? according to Lewis concept of base, those those species which have more electron density, that is more basic, which has low electron density, that is what you see, less basic. When you talk about what you see, second example like this, C2H5, that is the name of this compound is ethylamines. In this case, what you see, ethyl group is what you see, positive inductive. Why? Due to presence of this ethyl alkyl group. So positive inductive effect due to presence of electron donating group ethyl. So it causes more electron density upon amino group, so it is stronger base. So I think you have clear what are the negative inductive effect, what are the positive inductive effect. If asked in examination, explain why aniline is lane based, then what you see ethylamines, we have to at first give the structure of the aniline, ethylamine, then we have to explain with the help of what you see inductive effect, withdrawing group, and in this case withdrawing group, in this case what you see electron donating group, it causes more electron density overall, so it is more what you say basic. But in this case, due to presence of electron withdrawing group, phenyl group, it causes less electron density over the what say amino group, so it is weaker acid. Yes. So examination you ask sometimes, so what do you mean by inductive effect? Give suitable example. Next, explain why trichloroethanoic acid is more stronger than what is ethanoic acid. One question. Second question, sometimes ask you explain why aniline is less basic than ethylamine. So I think you have clear, so you can explain in the examination. Yes. So these are the very important for examination. So thank you for watching this video. Next day I will come with layer what is a very important video, that is what you see Colway's electrolysis. So in this case, very important question. Sometimes ask you to write out the short note on inductive effect, then you have to write all these. Sometimes ask you what is inductive effect, give example. Sometimes ask you explain why aniline is less basic than ethylamine, why trichloroethanoic is more acidic than what you see ethanoic acid. I think you can describe it easily because I have already written you all these things.